Hello and welcome back. Today I have three affordable voltage and frequency references. They suddenly appeared on AliExpress, and I already showed you one here, and it are boxes like this, gray. They are very nice packaged with plastic boxes, so they do arrive in one piece. And this is the YMC-05, but I also find now the YMC-06 and the YMC-06S, and I like to show you the differences. If you have been watching my channel for a while, you already have me seen using these little references. This is based on the AD584. It has 4 voltages, but you really need to rely on what they put here on the calibration. Also, of course, the DMM Check Plus, which is already a little bit more expensive. But of course, one of my favorites, the LBO2A, we also have. And it is pretty good, but it is already above 100. And of course, going better, you get more expensive. This one is really good. It's the Rytec. But of course, not affordable for everyone. So you can also do kits like this. This was a donation from a ham from California. This is the ADR 1001. It's a development kit, so we're gonna have a closer look at it at a later time. But what if you, for a lower price, want something accurate? That's why I thought it's interesting to have a look at these. So here we have 3 very similar looking boxes. This one is already there for a while. Then this one appeared shortly, and then you find it less often now, and now we have this one. Here we have only a voltage reference, and we tested this one. I linked the video below. It was pretty good. It came also with a calibration, and this checked out on my meters too. This was correct, so this was well done. Then we have this one. It doesn't come with a calibration value, but to say there is a 5-volt output, 0.01. We need to check if that's true. And also we have a frequency output of 10 megahertz. So let's have a look at those. And here we have another one. They didn't do the voltage reference anymore. They only said we do frequency output, but then we can do a sine wave and a square wave. And here, yes, we have a proper calibration was done. So we can check if that is correct too. First, this one, we saw it needs a little bit heat up time. It is the LM399, so absolutely it's good. They have very little components, so it is mostly based on just purely on the 399. And if you buy one, this is Tony approved. These values were correct from this seller, so this one is trustable, because it's nice if you buy them, you can buy them cheaper and then it's not calibrated, but yeah, then what is the use of it? So then we have the other two, the 2-in-1 and the 10 megahertz only. So this one provides a 10 megahertz, they say 0.01 ppm, and the voltage 0.01%. Well, this we need to check, and it says it is a square wave or a sine wave. Well, there is only one output, so we need to see what it actually is. 50 ohms output, that is for the OCXO, and a warm of 1 hour. Here we have frequency only, and they say it's a square and a sine. Well, let's say if they use the same OCXO, this is the normal square output that we have here also. Here you put your band pass 10 megahertz and you automatically get the sine. So that's probably what they did. Warm up half an hour. Let's see. Let's try this. Well, nowadays all these devices are powered with 5 volts. Usually it is switch mode what you have, and because this is a standard, I want to be sure not to have interference. So I have here a linear power supply. It is from Bruce Hi-Fi. It's just a linear with some filtering. So we have exactly 5 volt here with no interference from a switch mode, just to be sure. In another video I will dive into the 5 volts for the lab. And be careful if you buy this one. They say it's 15 watts, but that's only the transformer, because they just use an LM317 or equivalent of that. So that one can do 1.5 amp. So that means it is not 15 watts but 7.5. But anyway, it is nice clean power, and I will do another deep dive into this type of power supplies. So powering that up, I like it's convenient with the USB plugs just in the front, and I can connect a lot more here. Let me do also, because it's OCXO, so it needs some heat up time, and here we can monitor closely how much power it will take. So let's switch it on. This is the OCXO only. At startup we are here about 800 millis, almost 900. So that is heating of the OCXO until the oven is warm, and then it will drop. Let's see if we can do this one at the same time. Oh, it's all an amp now. So I need to be careful. I need to wait until it's warm. Now it dropped. It's now around 500. So it will go up and down until it probably stops around 300-400, probably, I think. So we can switch on this one too. I don't see a voltage drop, so the power supply is handling that well. This one uses a lot less power. So let's see what is the difference in these OCXO. Because I cannot think it is immediately hot. Okay, so let's keep this for a while. We can already start measuring the voltage. Well, they are not warm yet, but let's still measure the voltage. This is the YMC-06. So this is the one with frequency and voltage. So let me just do that. This is the frequency output. Well, we can see it is still warming, but that's clear because we haven't waited for an hour. Let me get here also the voltage that I will measure here. That should be 5 volt within 0.01%. I doubt that a bit because that is really accurate. But we are not in an hour yet, and I like to see what reference they use, but that was not specified. So we need to wait a little bit. Indeed, it's sort of 5 volts. I'm not that impressed, but let's wait for that. Let's see, by the way, if this one frequency here, if that is a square or a sine. Let's get the scope. This is the output of the YMC-06. We see it is a peak to peak of 4.5 volts, but of course this is without the terminator, so it doesn't look that good. With the pass-through 50 ohm here, the signal looks a lot better. But we have a loss less. It's 1.7, 1.8 volts peak, which is not that much. We see that this one is using less power. This is now 230 and a bit milliamps, while this one is still around 330. And yeah, I don't doubt they use the same OCXO, but somehow the circuitry here uses more power. So we can investigate that later to open. The frequency still needs to heat, so, but let me do the same here. The square YMC-06S without the terminator, of course. It doesn't look good at all, but it is at 3.4 volts. With the terminator, of course, it looks a lot better. I have the feeling that it looks a little bit less noisy than the normal 06, but still, it's good. The sine output looks really nice, and you expect that also from the band pass, of course. If I'm not using the terminator, it is 1.44 volt. So I wonder if I use the terminator how low it will get. With the terminator, the signal, of course, looks still good. But I wonder if you want to use it with a sine wave, because of the bandpass filter, the signal is already very low. You are only left with 830 millivolts. So this one stabilized around 200, it even dropped now just below, and this one about 300 and a bit. I think they are both stable now, and now it's just waiting for the temperature. This one seems a little bit hotter, but it also uses more power, so that would make sense. So let me get my temperature sensor here. This one is 42, 43 at the highest, and this one, yeah, 44, 45. Also the area of the right one is a lot larger. So here it is the OCXO, and here there is something else around it that is also heating. So let's open it up later. Voltage and frequency, okay, it has been on for a while. It has been going around this 5 volts, 129, 128, into 132, where we are now. So it seems kind of have stabilized. And the temperature, of course, inside of this box just varies with the oven of the OCXO. That is the idea behind it, that the OCXO kind of stabilizes the temperature within the box, and that is how the voltage reference stays at one temperature. So yeah, much more accurate as that we probably not gonna get it. The frequency, yeah, it is 0.1%, I think they said, and we were at, if we go to, is that correct? Yeah, probably it is, because that is this digit, I think. 3 here. But of course we can get it better. So I can adjust not the voltage, but I can adjust although I can also adjust the voltage. I think I have 2 pots here. That's interesting. Let me adjust the frequency. Yeah, we can see it dropping already, so we need to go the other way. I am comparing this now to GPSDO, my lab reference. Okay, I'm not sure if we can also adjust the voltage, if that actually does something or not. And then of course we also have another problem, because that pot could also influence the temperature. But it is adjusting quite good actually. Interesting. Huh? So you can get it, it adjusts nice. It's a 10 turn. But yeah, it doesn't come calibrated, but we didn't see a sticker on it either. But we can get it good. Look at this. This is 5. This is 10. Let's just leave this running and have a look in another 10 minutes. Let's see the frequency of the other one right here. How well is this adjusted? This one should have been adjusted at 21.3 degrees. Well, it is 23 in my lab, so it's a little bit hotter. And then we see all the zeros. Well, they didn't do a bad job, to be honest. So this one is also trustable. We are below the hertzes here, because we are at 10 megahertz. Look at that. It's not bad. It can be better with the GPSDO here. But they didn't do a bad job at all. So we can get it a little bit better. It didn't need too much, this one. And it's quite stable too. Nice. Let's open it up. We see, by the way, that the voltage is still not that stable, so I'm not that impressed by the voltage reference in the 2-in-1. So I like to know what it is. It's for sure not an LM399, and also by adding the pot you add an extra temperature component in it. Well, let's have a better look at all of them. Well, first the LM399, I did a little tear down on it already. We have the USB step-up converter. We have here some coils to make it nice. We have a 15-volt regulator here in the LM399, nicely with cutouts in the main board. And of course the op amp to create the other voltage. When we look at the inside, this is the 2-in-1. We don't see any shielding. Of course the OCXO is no surprise. It's a CTI or the Vector, widely available from old phone towers. Usually they are reused. I see nice cutouts in the board right here. And well, the power circuit is less impressive than we have seen from the LM399. Just a step-up converter, a little coil to smooth out the noise, and then they are feeding it directly. The two 10 turns here. And I wonder, where is this voltage reference? Clearly it's the CTI. The frequency comes directly out of the OCXO here. This is the voltage control, and here is the voltage for the reference. But I don't see directly where it is coming from, so maybe it's in the bottom, because here we have the input for the USB. Well, we have a little LED, you know it's connected. This is the step-up circuit, it seems. Here we have cap, and the coil is to clean up the voltage. And then where is the reference coming from? Because I think this one is the step-up converter. Well, I don't see anything on the bottom. So let's have a look again at that step-up. So the only IC I see is this one. That's the B6283T. Yes, this is indeed the step-up converter. I found it here, high efficiency 1.2, can deliver up to 2 amps. And well, clearly this is not the reference. Well, I found this on the ad from the seller, from one of the sellers that sells the 2-in-1. And they talk about that they use a Rev 5050 chip from Texas Instruments. And I didn't see it on the PCB, but so maybe they are talking about a reference chip that is inside of the OCXO, and I didn't know this one was in there. And you have indeed that voltage reference pin to adjust the frequency that has a very stable voltage. So maybe they use that voltage and output that. Also it says here it is 0.05, not 0.01. That makes more sense. So the sticker on the box is not that accurate, I think. So then we have a look at the OCXO only version, the one with sine and square. Again, no shielding in the box, but the main board looks a lot better. I see here again the USB, the step up, then it's being cleaned. We have a linear regulator here, and here we have the output circuit. This looks like a buffer. I think it's a 7404, they usually use that. Here we have some space open, because this is the square output, so they don't use the bandpass filter, and here they do. So this is just a copy. We can see that on the microscope, but I'm pretty sure that's exactly what it is. Here we have the input circuit. Well, it looks like that same step-up converter thingy here, only we have a lot more filtering here, and here we have the 7805, the linear regulator, nicely with all the caps also. And then we power this unit, and then the output of this unit goes through a buffer, and here we have the two outputs. What is it? Yeah, 7404, it's the hex inverter. It's commonly used for buffering. And well, here we see this is a typical bandpass filter, coils and caps to ground, and here it just goes out. So this is the sine wave output. Here it comes directly out of the hex inverter, and we see there is no filtering here, it just goes out. So a little sum up, what do I think? Well, I was very enthusiastic about the LM399, especially with the proper calibration values on the top. About the 2-in-1, I am not impressed at all. The voltage reference that it should be 0.01 can never be, because in the specifications we already saw it was 0.025, and that is when everything is ideal. If they use the reference from the OCXO. If they don't, then there is no reference at all, because we could only find the step-up converter. The OCXO, yeah, it's good, like any OCXO from CTI. They are just pretty good. Do I need to buy that's why this special box? I don't think so. And on top of that, it was also not calibrated, and it showed, because the frequency could have been a lot better adjusted, and the voltage absolutely. The OCXO with square and sine, I think was good. It was also calibrated, and it was very close to the frequency it should be. Also, it's maybe calibrated in the other part of the world, and because it's crystals, even though it's overnight, maybe it resonates differently because of gravity. So I give them the benefit of the doubt for that. It was properly calibrated. It was very close. So then we need to decide, is it worth the money? Well, maybe it is. It is around $40, $45, and there are other kits around that also are buffered that have the same OCXO and are maybe around 30. But the biggest plus I like here is that it has two outputs, the square and the sine, and it was calibrated, and then it is all in a box. Well, that's it. Thank you for watching, and I hope to see you next time.